So the last lesson in this unit is 3.8, and we're going to be solving equations by clearing fractions. So we're going to be looking at all these equations that have fractions in it, and instead of actually just going through the process of solving it using the fractions, which you can do, and we've been doing, there's a special way that you can clear fractions out so that all you have to deal with is whole numbers and still get the same answer. So that's the strategy we're going to be looking at today. So the main thing that you want to make sure you realize is there's lots of different ways to solve an equation. If you were going to walk through some of these and you had a scientific or graphing calculator that will very easily just handle the fractions, then that may be your best option. But we want to make sure that we also have this strategy in our back pocket if we want to use it. All right, so to clear fractions in an equation or in an inequality, it works the same way. You're going to choose a common multiple of all the denominators in the sentence. So a multiple is a number that all the numbers are factors of. So it's a number that they all multiply into. So for instance, a 9 and a 3, the common multiple there is 9. You also could have a common multiple of 27. Another common multiple would be 18. Both numbers multiply into 9. They both multiply into 18. They both multiply into 27. So all of those are common multiples. Then once you choose your common multiple, you're going to multiply each side of the sentence or of the equation or the inequality by that number. So basically the entire thing, every single term on both sides of the equation is going to get multiplied by that common multiple, by the number that every single denominator can fit into evenly. All right, and that is going to clear these fractions out, and I'll show you how that works. So if we look at the first one, again, you could use 27, you could use 18. Now the bigger the number you use, the bigger all these other numbers are going to become. So ideally you want to use the smallest possible number. That'll work. So both of these numbers can multiply into 9. And so that's the one that I'm going to use. So I put the 9 here. You can put the 9 here. You're just going to distribute it to every single term, both sides of the equation. And let's see what happens. So first of all, 9 times 16 gives me a new number of 144. Now, 9 times 1/3. If you did it up here, 9 over 1 times 1/3, you end up with 9 on top and 3 on the bottom. So what ends up happening is you're actually just dividing the 9 by the 3. So 9 divided by 3 is just 3. So this becomes 3m. And that's why we did this in the first place. We're multiplying by this common multiple to get rid of the fraction or to clear the fraction. So by multiplying by a number that this fits into nicely, it creates a whole number. So as we multiply the 9 over here, you're really just dividing by the 9 that's on the bottom. So you don't have to write it, but I just want to show it to you. We're multiplying 9 over 1 times 1/9. So you get 9 over 9. So really you're just dividing by this 9. Now, the reason that these are just basically division problems is because we have the 1 in the numerator. If there was another number up here, 2, 3, 4, anything, then we'd actually have to do something else. But since it's a 1, all we have to do is divide this number by the bottom. So 9 divided by 3 is 3. 9 divided by 9 is a 1m. So if you want to put the 1 there, you can. You don't have to. A 1m. And at this point, now I have a nice, easy problem to solve. So a 1m plus a 3m is a 4m. And so I'm just going to divide by 4. And m equals 36. So while this is new and you may be confused the first time going through, look how easy this made it. So it's worth looking for this understanding here. Because if you were trying to work with these fractions, a lot of you would kind of freak out. Wait, I have to combine these two because they both have m's? How do I combine 1/9 and 1/3 without a calculator? Or do I even want to do that in the calculator? And then try and clear that fraction out. So if we just clear the fractions out altogether, now it's just a very normal equation for us to solve. So that's the advantage to this. So while this may seem different at first and you may feel a little hesitant about it just because it's new, I want you to see how useful it is, that it's worth looking at and it's worth kind of picking up as a skill so that you can clear out these fractions. So as we take a look at the next one, we need to choose a number to multiply by. Now there's only one fraction, so you might as well just multiply by that number because it's just going to cancel itself out. So you're going to do 3 times 5 is 15. Then you're going to do 3 times this. Now again, this is really 3 over 1. So you're going to get a 3t on the top and you're going to get a 3 on the bottom, and those 3's have to be divided. So what you need to just look at is, okay, if I multiply 3, the bottom fraction that's a 3 is going to clear out. So all that's left when I do this is just a minus t. Now I just made it capital just so it doesn't look like a plus sign because I know my own handwriting. You could leave it as a lowercase. So I got 15. The 3's canceled, leaving me just t. And then you must multiply everything. Don't just multiply the left side, everything. And so I'm going to get a negative 21. All right, almost done now. So just minus 15. As we've talked about, don't add it because you see a minus sign. If you added 15, you'd get 30. We need 0. This minus sign has not been affected. Leave it. So I get negative 36. And now I do want to get rid of that, so I'm going to divide by negative 1. And all that does is change the signs. So a negative becomes a positive, and a negative becomes another positive. So even if you had multiple fractions, if they all are just one number, if there's only one number you're trying to clear out, then multiply by that number because it'll just cancel it. Just like over here, basically the 9's canceled, leaving you just a 1m. All right, and then we divide it on this one. So let's take a look at the last one here. Got a 10 and a 5. So one common multiple would be 50. You could multiply this by 50 and it would clear out the fractions. You could multiply it by lots of different numbers, 40 and 30 and 20. All of those can fit 10 and 5 into them evenly, but the smallest number that they both fit into is 10. So that's the best number. The other ones will still get you the right answer, though. That's important to realize. So 10 times 1 is 10, minus. When you multiply it and it has the same denominator, they just cancel, so it's just minus n. Now this is an inequality. Notice I didn't multiply anything by a negative, so I'm not going to flip it. If you, for some reason, chose to multiply everything by a negative number, you'd have to flip it. Okay, and now I'm going to multiply here. It's going to be a negative number. Here's how you handle it when you got a number that's not 1 on the top. You can do 10 times negative 4 and then divide by 5. But the whole reason we were choosing 10 is because it works so nicely with the 5. So I like to do the division first, which you're allowed to do. So instead of doing 10 times the 4 and then divide by 5 at the end, what you can do is 10 divided by 5, which is 2, and then times it by the 4. So 10 over 5 is 2 times 4 is negative 8. So if you wanted to see it the other way so it makes sense, you could multiply straight across 10 over 1 times this, and you're going to get negative 40 over 5, which is negative 8. Or it's kind of like putting the 10 over the 5 and timesing by the 4. 10 over 5 is 2, and that also gets you the 8. So you can look at this and you can divide first and then multiply. I think that's the easier way to do it. But at the same time, you can just multiply straight across and simplify. But the whole reason we chose that 10 was so that it knocked itself down real quick with the 5. So I think that's the best strategy. Okay, now we've got all whole numbers, no fractions to deal with anymore. Minus the 10. This is a negative n. This is a negative 18. Now, be careful here. We're going to divide by negative 1, right? That's how we get rid of this. So we have n and we have 18, but we just divided by a negative number. So since this is an inequality, we need to make sure that we flip it. And there's our final answer. All right, I want to look at one more example where we have multiple fractions, 3 of them in fact, that we want to clear out. So if I look at the numbers 6, 36, and 4, I got to find a number that they all fit into. So I hope we realize that 36 is that number. Obviously, 36 fits into itself, 6 goes into 36, and 4 also goes into 36. So what I can do is I can multiply this entire thing by 36. Now I've purposely put these numbers on all varying sides just so you can see it's the same thing. It doesn't matter if you write it on the right or you write it on the left. You don't have to draw these little lines either, but it's just a nice reminder to multiply everything by the 36. So if we start over here, the 36 times the negative 7, it's negative 252. And now let's work our way through this. So when we multiply times the x over the 4, okay, it's going to stay negative. What you're going to do is you're going to do the 36 divided by 4. You just divide by that bottom number. And now there's no number up top to multiply by, so it's just going to be multiplied times x. So it's just attached. So 36 divided by 4 is 9. So you get a 9x. And again, this is why we're doing this in the first place. We want to clear out all these fractions and just make them whole numbers. So we're going to multiply everything by 36. So when I multiply this by 36, they just cancel, leaving me 17. If you had gone straight across, you'd have 17 times 36, 36 times 1, the 36 cancels the 36. And now when I go times this, I can simplify the 36 over 6, divide, and that's 6x. This now is a whole lot easier to look at than all of these fractions, is it not? So let's simplify this side and then solve it. So you're going to put the 6x and the minus 9x together. So that's going to be a negative 3x plus 17. And now all of us would feel very, very, very comfortable solving this. And if I gave you this, you may not feel so comfortable. So this skill is very important and very useful in certain situations. So let's finish this out. Minus 17 on both sides. That's negative 269 and divide by negative 3. It's not an inequality. I don't have anything to flip. A negative divided by a negative is a positive. Now, that's not going to give you a very nice number. Let's take a look at what it looks like. So 269 divided by 3. It's 89 and then something left over. So if you wanted to, you could leave this as 269 over 3. You'll very often see that kind of answer in the textbook. Okay, nothing wrong with that. You can leave it like that. So this is fine. You also could turn it into a decimal. 89 and 6 repeated. Okay, that's a good answer. Now you can't just round it and not put the repeated. The repeated is important. So now we have an exact answer. And we need to start learning what 6 repeated and 3 repeated are. So 3 repeated is 1/3. 6 repeated is 2/3. So another answer for this is 89 and 2/3. If you put 89 into 269, you'd end up, if you put 3 into 269, it's going to go in there and it's going to hit 267. You're going to have 2 left over. So 3 goes in 89 times and there's 2 left over. But we should start recognizing in our calculator when we start dividing by 3 and we get 0.3 repeated or we get 0.6 repeated, that's 1/3 and 2/3. It's really going to help us out. I do want to add one quick example here. So if you would write this one down. Let's call this example 3. The reason I want to go through this is because so far everyone we've looked at, one of the numbers that was a denominator ended up being the number that we chose to multiply by. So there was a 9 and we multiplied by it. There was a 3, we multiplied by it. There was a 10 and there was a 36. So there's not always going to be a denominator that we multiply by. So if I want to clear out these fractions, I need to find a common multiple between 4 and 3. So 3 is not going to fit into 4, so I'm not going to multiply by 4. That won't clear out the 3. If I multiply by 3, that'll clear this out, but it's not going to clear this one out. So I got to pick a number that they both fit into, okay, and that's 12. So I'm going to multiply by 12, and let's see what happens. So if I multiply this by 12, I've got the 1 on top, so all I have to do is divide. So 12 divided by 4 gives me a 3x. 12 times the whole number 3 gives me 36. And then I have to do 12 times 1/3. So that's just 12 divided by 3, and that's 4. Okay, so that's the important part. I know we can solve the equation from here, but that's how we clear it out. Okay, find the number that they both fit into. The common multiple is the vocabulary that you should be using. And then you're going to multiply by that. I'm not even going to finish this out. I know we can solve this equation. I just wanted to show you that if these numbers don't fit into each other, you find the biggest, or not the biggest, the smallest number that both of them will also fit into, which is called the least common multiple.